Alright, so yesterday we talked about graphing inequalities. Today we're going to do a little bit more practice with that as well. You have a foldable that I just passed out to you. This foldable is going to be used for 2 different days. It's going to be used for today, and it's going to be used again on Monday. Now, I need you to put your foldable like this, facing up, and you are trimming off the extra white. So you're just cutting around the black rectangle on your paper. And make sure it is facing up like this, because if you flip it over and you cut it this way, you're gonna cut off information that you need. So again, make sure it is facing up where you see inequalities on the front, and then you see a little dab of blue will do. Then once you have that, you can go ahead and fold it in half again, so you are looking at just this. Now, if you do not know the inequality symbols, this is a great foldable because it's got all the information you're going to need right on the front of it. So this is the less than symbol, greater than symbol, less than equal to, greater than equal to. And it also has the information about graphing on the bottom. So it says, represented on a number line with an open circle. And it goes at, it even draws a little picture of a circle that isn't filled in, and then 2 circles that are filled in. Once you have it cut out and folded, go ahead and then cut the flaps, but do not cut them all the way. You are only cutting up to the inequality line. Here. Just pay attention, son. Look. Alright, we are going to go ahead and get started. Now remember, yesterday, hopefully it seemed like by the end of the class period you guys had a decent amount of confidence with this. It wasn't as hard as you thought it was going to be. And I hope that continues today. Now, obviously, yes, we are moving into more difficult stuff later on down the road, but today, again, it's just more practicing what we did yesterday. So, flip up your inequality symbols, and we essentially are looking at just the top for today. So this says x is less than 3. So which direction is our arrow going if our variable is located on the left side? Garrett? And how do you know that, Garrett? And that applies when your variable is on the left side. Alright, so if I'm going to graph this, I'm going to locate 3. Kayla, will you turn on the light, please? Just one. I'm going to locate 3. Am I using an open circle or a closed circle? If you do not remember, you can flip the flap down and it tells you, right? Alright, so open or closed circle for the 3. Isaac? Open circle. And then Garrett told us that we are going to the left. So I'm going to draw my arrow to the left. And then just to make sure that this is true, what can I do to check my work? What can I do to make sure that that is true? Lauren?
Use a number for x.
Okay, so use a number for x. 2 is less than 3. Alright, so what this is telling us is that all numbers below 3 are a solution. And the key word there is below, so if you want to underline it, highlight it, circle it, whatever, that's fine. And then Lauren said 2 is less than 3. Alright, how do we feel about that one? Okay. Alright, slide over to the next one. X is greater than 3. So how do we know which direction our arrow is going? Brayden?
Right,
It's going to the right, and you know that because why?
because x is going to be a bigger number than 3.
Okay, so X is going to be a bigger number than 3. We know that our arrow is going to the right. It also tells us, because our variable is located on the left, that the inequality will tell us on the right. So when I go to graph this, I'm going to locate 3. Am I using an open or closed circle? Haley? Open circle. Thank you for using your foldable. That's pretty much why it's there, right? To help you out. Alright, Kaylee, which direction is my arrow going?
Going to the right.
And then Kaylee, pick a number to the right that makes the statement true. 8. So 8 is greater than 3. Perfect. So this one is all numbers above 3 are a solution. And then Kaylee said 8 is greater than 3. Alright, questions about the first two? Alright, slide over to the next two. So the next one is X is less than or equal to 3. So what do we know about the arrow in this one? What do we know about our arrow? Which direction is it going? Allie? Huh? Going to the left? And you know that because why? Can't hear you. Because it's less than 3? Guys, what is the reasoning though? Like, yes, because we know it's less than 3, but again, this is a skill that I'm trying to reiterate with you guys so that you remember when the variable is located on the left. It's super easy and it's very beneficial. Garrett?
The symbol is pointing to the left.
The symbol is pointing to the left, so therefore we're going to the left. Again, when the variable is on the left side, the variable switches, then obviously that doesn't pertain. But when the variable is on the left side, you can do that. Are we using an open circle or a closed circle? Leah?
Close.
How do you know?
Because it's less than or equal.
Less than or equal to, so we can include that number. All right, I'm going to the left. And then Leah, give me a number to the left of 3. That makes the statement true.
1 is less than. Wait, hold on.
What?
1 is less than.
Speak up, please.
1 is less than
1 is less than 3. Yes. So what this is saying is that all numbers, including 3 and below, are a solution. And then the example that Leah gave us was 1 is less than or equal to 3, and you can also do 3 is less than or equal to 3. And everybody understands why we can include that 3 there, right? Is there anybody who doesn't understand? Make sure with this one that you highlight, underline, circle, whatever, including, because that lets us know that we can put 3 in there as well as the numbers below it. And then the last one, x is greater than or equal to 3. Which direction is our arrow going? Kira? And how do you know? Nope. How do we know that our arrow is going to the right? Michaela?
The side is pointing to the right.
The side is pointing to the right and our variable is located on the left. All right, we know from the previous one that we are using a closed circle. So we're going to do that. And then which direction is our arrow going? It's going to the right. Michaela, give me a number that makes my statement true.
9 is greater than 3.
So 9 is greater than or equal to 3. So this one is all numbers, including 3 and above, are a solution. And Michaela said 9 is greater, 9 is greater than or equal to 3, and again, we're gonna include 3 is greater than or equal to 3. And then make sure that you highlight the word including. All right, go ahead and glue this in on the writing and graphing inequality. Oh, please glue this in because I do not want you to lose it because again, we are coming back to this on Monday. All right, so I obviously want you to have your foldable out and about so that you can use it for this next part. And again, we're not doing this entire page today. We are actually doing part of it. And then we're gonna do the other part on Monday. We are just practicing writing and graphing today. That is all we are doing. If I'm using a black pen, what are you using? A pencil. First period was struggling with the concept of using whatever color they wanted, and then they were making mistakes and they're scribbling out, and it just got super messy. Yes, you will be able to use a pen, color pencil, marker, crayon, whatever you want at some point, but when I'm writing with a black pen, please be writing with a pencil. All right, so the top part of this is the writing aspect of inequalities. So we started Unit 6 with translating expressions. This is essentially the exact same thing, except for you're putting an inequality symbol in instead of an equal sign. We're gonna do these together, so just do the best you can. Participate as much as possible, makes it a little bit easier. So it says a number minus 5 is at least 16. So our key words here, at least. What is that telling me? Is it going to be equal to a number? Yes, so I'm gonna start with the bottom half of the inequality symbol because we know it's going to be equal. Okay? We don't know yet if it's greater than or less than, but we do know it's going to be equal. All right, the next part, a number minus 5. What is that going to look like? A number minus 5. So x minus 5. And then, so a number minus 5 is at least 16. What number is going on the right side? 16. Perfect. All right, so for the most part, that was not terrible. It's just kind of breaking it up into the pieces that we know. Now, here's a little bit more difficult part with this one. Is it greater than or is it less than? So what do we think? Bella?
The greater than,
Why?
because it says the number is at least 16, so it can be minus 16.
So it can be more than 16, but it cannot be less than 16. All right. So that is writing an inequality. Okay? Again, not terrible. Not the easiest thing to do, but it's not terrible. All right, let's go down. So it says 4 times a number is no more than 40 3/4. So the key words we're looking here is no more than. So that's telling us what? Greater than, less than, greater than, equal to, less than, or equal to. What is that telling us? Garrett?
Less than?
Less than. Okay? And then 4 times a number. What is that going to look like? 4 times a number. Nevaeh?
4 times x.
Okay, so we're just going to put 4x. And then 40 3/4. What is that going to look like?
40
Right. It's going to look like 40 3/4, right? All right. That one a little bit easier than the other one. All right, going up to the top right. A number increased by 10 is less than 30. So less than is telling us what? Telling us what?
less than something.
Okay, so Garrett, I have a question. Is that open to the left or does it open to the right?
To the right.
If it's to the right. And then a number increased by 10. What does that mean? Right.
X plus 10.
X plus 10. If you don't sit still, I'm sending you out. Because everything you're doing is being picked up by the video. So stop, please, and just follow along. So a number increased by 10 is less than 30. So what's the last thing we need to add? 30. All right, and then the last one. The quotient of a number in 6 is more than 2 3/10. So more than. What is my inequality symbol going to look like? Is it opening to the left or to the right? Awesome. All right, what comes, I would say what comes next, but what do we do next?
X divided by 6.
And then what's last? What is last? Awesome.
2.3.
So you can do 2.3 or you can do 2 3/10, whichever one you want to do. All right, so what do we think about those? Wasn't terrible, a little bit scary at first, but if you break them down piece by piece, it's a lot easier than looking at it as a whole. Because looking at the question of a number in 6 is more than 2 3/10, that's a whole lot more to look at than to break it down piece by piece. So just a strategy you guys can use. All right, let's look at the word problem. So Max's vet said his puppy will grow to be at most 33 inches tall. The puppy is currently 1 foot tall. Write an inequality to show how many more inches Max's puppy will grow. All right, what's important in that first question? Rated?
At most.
At most. So at most means what? Is it going to be greater than 33 or is it going to be less than 33? Jeffrey? So at the most,
Oh,
less than. All right, so I'm going to start with my less than symbol because I know already at most means less than. What else is important in that first question, or first sentence, sorry? What else is important in that first sentence? Sebastian?
There has to be
What else is important in that first sentence? I don't wanna know about anything else but the first sentence. So in this first sentence right here, what else is important?
that it can be 33.
So 33 inches tall. What is that 33 inches representing? The whole or the total, right? So that is technically our answer. That is the most, that is where his growth will stop. So that is the total that he can be. All right, the second sentence says the puppy is currently 1 foot tall. What's important in that question? Lauren, 1 foot tall. So Lauren, I have a question. What's the problem with 1 foot tall and 33 inches? Right, so can we convert the 1 foot to inches? And how many inches are in a foot? So 1 foot equals 12 inches. All right, so now I know a part of the whole, because I know that the dog is 12 inches tall right now. And then our question is saying, write an inequality to show how many more inches Max's dog will grow. So 33 is going to go on the left, because it cannot be greater than 33. We know that the dog is 12 inches at the moment. So how many more is telling us what operation? What operation, Jeffrey? Addition. So we're going to do plus X. Okay? How do we feel about that one? Yes?
Can it with, at most, make it be less than 4 equal to?
Yeah, that's what I was thinking.
Because it
Could it
could
be-
be equal.
Oh, yes, you're right. I'm sorry. I forgot that part. You are correct. Because he can be 33 inches, but he can't be more than. You're right. My fault. No, you weren't.
What was I
Goodbye.
say that when I was in my hand?
No, both of y'all are ridiculous. All right, so the next 5 you are doing on your own. I recommend you using a pencil, but if you feel 100% confident in your ability to graph, then you can use a pen. That is completely up to you. I'm going to give you 5 minutes. It should not take us that long. If you finish within that 5 minutes, go ahead and stand up. If you don't, that's fine. When you stand up, I am going to come around and look at your papers. So go ahead and get started with that. Yeah. I was super confused. Thank you. We're only doing the bottom 5 on the left side. If you attempt to do the right side, the bottom area, you're going to lose your mind and your head will explode within this classroom. Okay, so let's go ahead and go over this for the most part. Looks like the majority of us are done. Alright, so x is greater than negative 8.5. So someone tell me where my point is going to go. And then tell me if it's going to be open or closed, and then tell me if I'm going right or left. Right in.
It's gonna go between -8 and -9.
Okay, so like right there?
Yes.
Okay, and then what type? Open. And then what else?
It's going to be, the arrow's gonna be facing towards the right.
Okay, and then give me a solution that makes the statement true.
8.
So 8 is greater than negative 8.5. Perfect. All right, next one. X is less than 2 3/4. All right,
It's gonna be between 2 and 3.
like in the middle, closer to the 2.
Closer to 3.
Okay.
And it's gonna be, open, and it's
So closer to the 3, open, and you said it's going to the left?
gonna go to the left. Yes, ma'am.
All right, and then give me a number that proves your statement.
3 is less
No, because 3 is not less than.
3 is greater than.
No, baby. What you just told me, x is less than 2 3/4.
Oh.
So pick a number.
-3 is less than 2.
Yes. All right. The next one, x is less than or equal to 7. All right, Garrett.
You're pointing at 7.
Okay.
It's a closed circle, and we're going to the left.
And then give me a number that makes that true.
1 is less than or equal to 7.
1 is less than or equal to 7. Perfect. All right. So let's go ahead and we're going to skip the next one and we're going to go to the last one. Because the last one's a little bit tricky. So the last one, we have 2 numbers to plot and then draw an arrow. Right?
No.
No. Why not no?
Why wouldn't you just subtract it and put the number that you get from subtracting on the number line and then get x?
Oh, you mean it's that simple?
Yes.
No way.
Yes.
Are you sure? Are all y'all sure? I don't believe. I don't trust any of you all. Because math can never be just that simple as doing subtraction. And
If you trust me, I'll bring you coefficient.
I'll bring you,
I'll bring you bang.
Is that bribery?
I'll bring you the cotton candy.
definitely sounds like blackmail, but I'm super tempted. No, actually, I am going to trust you guys. And the point is, it's that simple. Like, it really is that simple sometimes, just to simply do your subtraction and then plot your points. All right, so 6 is greater than x. All right, so Noah, where's my point going to be?
At the 6.
Okay, and open or close?
It, open.
All right, and then which direction?
I'll put the line over the left.
Okay, but my arrow's pointing to the right.
But if you do it the way that the arrow's going is supposed to go, then it's not going to be right. Because 6 is supposed to be greater than x, not x being greater than 6.
So if you did this, you did not check. The reason you did not check is because, as Noah just said, the inequality says 6 is greater than x. If I draw my arrow to the right, I'm saying that 6 is greater than 7. Is that true? No. So this is one where you have to be careful because your first 3 all have your variable on what side? On the left side. So that is perfect because that applies to our rule, right? But do not forget, when the variable is on the right side, you actually do the opposite. So if your variable is pointing to the left, or sorry, to the right, you're actually going to draw your arrow to the left. So how many of you guys made that mistake? And that's okay. I expected it because, again, we've been, for the last day and a half, look at your inequality, look at your inequality, look at your inequality, right? All right, so now let's go to the next one. -4.5 is less than or equal to x. All right, so where's my point gonna go? Lauren? -4 is it open or close? Stop.
Close.
And then is it going to the right or to the left?
To the right.
To the right? Okay. Why didn't we not go to the left?
Because the x is not on the left side.
Because the x is not on the left side. If I go to the left, I'm saying -4 is less than or equal to -8. Is that true? No, it is not. -4 is less than or equal to 3. That is true. Okay? All right. So other than these two, how did we do with that? Okay, how many of you guys kind of picked up on the trick they did down here? Okay, good. All right, this top part is really easy, I think. We're just simply going to be writing the inequality that they have graphed. So the first one, I'm gonna go ahead and put my x on the left side because I don't wanna confuse myself. So all of my x's are on the left side for the top 3 on the right side. Now, this top one has a closed circle on 6, which means what? Brayden?
It's gonna have the line under it.
It's gonna have the line under it, and we know that it's on the 6, so that's our number. So now we just have to figure out, is this x is less than or equal to 6, or 6 is greater than or equal to 6? How do we know?
Less than.
How do you know?
Because the arrow is going less than 6.
Right, because the arrow is pointing less than 6, and then what's the last line of defense, per se, to make sure you did this right? What can we do? What can we do? Austin?
Change x to a number that is less than or equal to 6.
Okay, do that for me.
-6.
-6 is less than or equal to 6. Perfect. All right, the next one. So tell me the number. Tell me if you're doing what type of inequality, and then what. Just kind of walk me through it. All right, is it?
So, it's going to be greater than.
So you're saying x is greater than. Okay. Why did you not put the equal to underneath it? Okay, and then substitute a number in and make the statement true. Right, 10 is greater than -3. Perfect. All right, the last one. Get a volunteer to walk me through that one. Ryan.
We're gonna have to put the line under the number 1.
So you're saying x is greater than?
No.
Oh,
1 is our other number.
okay. There we go. All right, so x is less than or equal to. So last thing, Ryan, plug a number in that's less than 1. -2 is less than or equal to 1. All right. Open up your notebooks. This needs to get glued in next to your foldable with today. You can go ahead and trim this bottom piece off so that it fits in a little bit better. And then you are working on